write x, or I'll go ahead and write z is equal to x multiplied by 2. Okay, and this time I'm just going to use this z over here. Okay, still it is giving an error. Why? Because the list is not there, I guess. Code, let's see, x multiplied by 2. I'm actually okay. That many number. Okay, it is increasing the number of elements. Okay, so that is the problem, and that is the reason why we were getting this error. Okay, so because it is increasing. Okay, I'm just going to keep that particular error like that. So please, whenever you see an error, don't hesitate to probably solve that. Okay, and stop worrying about the errors sometimes, right? So that is one example. Because when we are doing multiply by 2, it's just appending more elements. Okay, but we can perform any mathematical operation just by using list comprehension or anything that you really want. Okay, I can use a for loop, whatever things you want. So this basically becomes a 2x2 plot, where in every block I have actually done the plotting. Okay, so perfect. Now let's go ahead and discuss about the bar plot. Okay, so let's go ahead. Discuss about bar plot. Now what exactly is bar plot? Let's say I want to plot something related to categories. So I have categories like A, B, C. I have A, B, C, and let's say I have D, I have E. Okay, so these are my categories. Now let me just go ahead and write my values. So it is nothing but 5, 7, 3, 8, 6. Okay, now let me just go ahead and create a bar plot. Now for every category, I need to plot the specific value in the form of buildings, right? Bar plot is nothing but it is just in the form of buildings. It'll be a good visualization, a most common visualization mechanism used for data, right? So I will just go ahead and write plt.bar, and here, first of all, I'll give my categories. Second, I'm going to probably give my values, and the third, I'll just go ahead and give my color. So let's say I'm giving a color called as purple, right? And if I go ahead and execute it, this is how beautiful you are able to see. A color called as purple, right? And if I go ahead and execute it, this is how beautiful you are able to see with respect to a category I'm having. And if I go ahead and execute it, this is how, so let's say I'm giving a color called as purple, right? And if I go ahead and execute it, this is how beautiful you are able to see with respect to a category I'm having this 5 value, right? With respect to B category I'm having this 7, C category I'm having this 3, right? And this is how you can specifically use. Along with this, you can again go ahead and play with all the other parameters like X label, Y label, title, and show. Once you execute this, you'll be able to see this. Okay, so here you can see almost each and everything we have discussed about the bar plot also. Let's see another amazing plot, which is basically called as histogram. So for this, I've already written the definition for histogram. Histogram are used to
represent the distribution of data set. They divide the data into bins and count the number of data points in each bin. Histogram are used to represent the distribution of data set. They divide the data into bins and count the number of the data in each bin.
to represent the distribution of the data. See, it is very much important. If you have a data set and you will be probably working with a CSV file, you'll be working with different huge data, and each data, it separately has different features, and each feature, if it is a numerical feature, it follows a different distribution, right? So in order to represent that particular distribution of a data, we specifically use histogram. It will show us how the data is, whether it is in a normal distribution curve or whether it is a Pareto distribution, different types of distribution. Over here, we divide the data into bins and count the number of data points in each bin. Okay, so let's say if I have numbers between 1 to 5, okay, I'll just create a sample data for you and then I will make you understand. Okay, let's say over here I have all my numbers between 1 to 5. It can be a repeated numbers. And all. Now what we'll do, we will try to divide all these numbers based on bins, right? And this bins will be specifically equal. So let me just go ahead and create a histogram over here. Okay, and let's say that right now I'm just going to use 5 bins. So I'll go ahead and write plot.hist, and here I'm going to use data bins is equal to 5. Okay, I'm saying, hey, please take this particular data and divide this into 5 bins, right? So if you all are able to see over here, this is my first bin, 1 to 1.5, 1.5 to 2. Okay, and let's say that right now I'm just going to use 5 bins. So I'll go ahead and write plot.hist, and here I'm going to use data bins is equal to 5. Okay, I'm saying, hey, please take this particular data and divide this into 5 bins, right? So if you are able to see over here, this is my first bin, 1 to 1.5, 1.5 to 2 is my another bin, and like this, what I can actually do with respect to every bin, and here you'll be able to see, okay, this is my bin, 1 to 1.8, 2.6, 3.4, 4.2, and 5. These are all my bins, and this is with respect to all my numbers. Then within this particular range, how many numbers are present? That is what is the height shown over here, right? So that we'll discuss about it. Along with this, you can also play with more parameters. I'll go ahead and write color is equal to orange, okay, and then we will go ahead and write edge color is equal to black, okay, black. So let's go ahead and see this. Now you can see that my diagram looks much more better. So this is between 1 to 1.8. One number is present. 1.8. That is what is the height shown over here, right? So that we'll discuss about it. Along with this, you can also play with more parameters. I'll go ahead and write color is equal to orange, okay, and then we will go ahead and write edge color is equal to black, okay, black. So let's go ahead and see this. Now you can see that my diagram looks much more better. So this is between 1 to 1.8. One number is present. 1.8 to 2.6. I think 2 numbers are present. 2.6 to 3.4. This much numbers are present. So we just go ahead and count it. See, between 1 to 1.8, only one number is there, right? And you can see between 1.8 to 2.6, how many numbers are there? 2 is there. 2.6 to 3.4, how many numbers are there? 3 is there, right? So 3 is there, right? Then for between 3.4 to 4.2, how many numbers are there? 4 are there. Similarly, with respect to 5, 5 are there. And that is the reason you'll be able to see this kind of histogram. But most commonly, it is used, and you will be knowing that with respect to distribution, if I just smoothen this curve, I'll be able to get the distribution of the curve, right? So this is the most important thing, and this is how my diagram looks like. You can also go ahead and zoom in, zoom out. Based on this, you'll be getting an option over here on the right hand side. You can also save this. You can also copy this and paste it anywhere you want. Okay, this is how you go ahead and probably create a histogram plot. Now we'll focus on creating a scatter plot. So let's go ahead and create a scatter plot. So here, with respect to scatter plot, what I'm actually going to do, I'm going to probably create my sample data. So this will basically be my sample data, and then I'm just going to write plt.scatter, and here. I'll just use my x and y coordinate, and again a very important plot, and you'll also be seeing all these kind of plots we will be using. So here you can see I'm just using marker is equal to nothing but it'll be x. So if I go ahead and see it, I'm getting some error. Okay, it is maker, or I have to write marker. Okay. So once I use this, so here you'll be able to see my data points will be scattered somewhere like this, right? So with respect to any kind of data points, you'll be able to create a scatter plot just by using plt.scatter. Okay. Now coming to the last one, which is called as pie chart. So pie chart, if you've seen a lot of presentation from managers and all, they really create a lot of pie charts specifically over there. So we'll try to see. So let's go ahead and define a pie chart. In pie chart, we specifically require one thing is labels. Let's say I have 4 labels, A, B, C, and this is my fourth label. And let's say along with this, we define some sizes, some values. Okay, so I can go ahead and write 30, 20, 40, and 10. Okay, so these are the values. And then along with this, I'm just going to use colors. And with respect to colors, I'm just going to go ahead and write, let's say gold will be one color, yellow green is going to be one other color that I'm actually going to use, light coral is will be one color. Along with this, we will also use light sky blue, right? So these are the various colors that we are going to use. Along with this, we are going to create a variable called as explode, and here you can see 0.1, 0, 0. Okay, so 4 values you'll be able to see over here. Okay, and the reason why I'm using explode, I'll just let you know. Right now, just keep this particular value over here. Okay, let's say that I want to explode to 0.2. Okay, now let's go ahead and create a pie chart. Now for creating a pie chart, I will be using plot.py function, and first parameter I'll be giving my data. Data, which is my sizes. Then I will just go ahead and assign my labels, whatever labels I've actually defined. Okay, if I execute it, here you'll be able to see A, B, C, D. Right, A is nothing but the 30. Then 20, B will be 40, sorry, C will be 40 over here because C is 40, and D is 10. Okay, and here you can see with respect to different colors, I'm able to see it over here. Perfect. Yellow, green, and all. Now along with this, let's go ahead and apply some colors. So here I'm just going to say, hey, colors will be this specific colors that I've actually mentioned. Okay, so now it looks pretty much good. Be this specific colors that I've actually mentioned. Okay, so now it will be this specific colors that I've actually mentioned. Okay, so now it looks pretty much good with respect to all these colors I've actually assigned. By default, some colors were there. Now I need to also display with respect to how much percentage is with respect to every slice, right? So here I'll be using one more parameter which is called as auto PCT, auto percentage, and here I'm going to use percentile 1 dot 1 f, that is floating percentile. Okay. So I'm going to basically write like this: percentile 1 dot 1 f percentile and percentile. So any number of decimals, but at least one digit should be there before the decimal and one digit should be there after the decimal. Okay, and here now if I go ahead and execute it, here you'll be able to see the percentage: 20.0, 30.0, 10.0, 40.0. Okay, there is also another parameter which is called as shadow. Okay,